Hi guys, this is Miss Castillo. How y'all doing? I miss you guys so much. Sounds so weird to say, but I miss coming to work. As you guys know, I will be back Thursday. I posted a note in Google Classroom last week. I don't know if you saw it or not, but it was kind of a big note explaining how it still really hurts when I talk. I can only talk for about 10-15 minutes and then my throat starts to swell up again. If you forgot what happened to me, I had surgery. I had my tonsils removed. So I have these two giant sort of scabby holes in the back of my throat that are trying to heal. So eating is difficult, talking is difficult, everything's just kind of swollen back there. But anyways, I feel pretty darn good. Like I'm not tired or sleepy anymore or needing to rest, but it's just hard for me to talk. So I'll see you guys back Thursday. Since you guys are my last class of the day, I'm going to make a guess and say that my voice will be pretty much pooped out by the time I see you guys on Thursday. So we'll see. We'll see how it is, guys. I don't know. I can't take any more days off work beyond Thursday, so we'll see how my voice is. If you're saying, "Oh, hey, Miss Castillo, welcome back," and I just nod and smile, that means my voice hurts and I'm tired of talking. So don't take it personal. Okay, well, you're about a week and a half into functions. We've got these doodle notes here that we're going to fill out together. And I know I've told you guys this before, but sometimes one teacher will totally vibe with you and you understand how they explain things. And then another teacher can come along and you have no idea what they're saying at all. And so it can be kind of frustrating. So I thought it would be nice to hear my explanation of what a function is, how it's different from what we've been doing instead of Mr. Rabbit today. So since this is an Edpuzzle video, there will not be any questions embedded. You just have to watch this video from start to finish and you will get credit for doing the doodle notes. You obviously want to have the doodle notes paper in front of you. So pause the video right now if Mr. Rabbit hasn't passed it out to you yet, because you need this. Okay, here we go. What is a function? All right, let's go ahead and you can doodle as I fill out stuff and explain. Okay, so basically a function is, they're telling you, here's this expression, plug in this, and then what's the output? What's the answer that I get? So they oftentimes will refer to it as a function machine, like a little machine. So we're gonna put a number into this machine, and then out is gonna come an answer. So what goes into it is called the input, and what comes out of it is called the output. So I'm just going to say, okay, what if my function machine was telling me to take every input x, times it by 2, and add 1. All right, well, let's see. What if we input the number 1? So we can mental math this. On my iPad, I don't have a stylus pointer, sorry. I'll just kind of draw little mini arrows, but we're gonna input that 1 right there. So 2 times 1, 2, plus 1. What comes out? 3, right? Okay, and then I can grab my eraser and I could say, okay, let's try a different one. Let's try inputting 4. So now I'm gonna put 4 in the function machine. 2 times 4, 8, plus 1, what comes out? 9. So that's all a function is. And you might be like, well, how stupid. Don't we know how to do this already? Haven't we been doing this whole time? Yes, we have. We have, absolutely. They're just now calling it a new name. That is all. But the math behind it, you guys can do this stuff in your sleep, right? This is easy. They've just got all kinds of new names and things that they use with functions. Okay, so now you know what a function is. You put in a number, you do the thing, and out comes your answer. Now the input has a lot of, I'm going to switch back to red here. It has a lot of different names. This is also referred to as, this is all the X values. All the X values are the numbers that are input there. And then the number, the answer, the output that comes out of the machine is all of the Y values. All right, now you've also been learning about independent versus dependent. You had a cutting and sorting activity on Friday. I can't think off the top of my head what some of the little cards were, but I think one of them was grades, like how much you study is going to directly affect what your grade comes out to be, right? So whether or not you're doing homework, you're practicing at home, that's the independent. And then the output, the result of that is what class grade you end up getting, or you could say what test grade you end up getting. Another example that was on there, I know there was one about a speeding ticket. There was one about a football game. And you had to figure out what was independent and then what was dependent. So what depended on what? So the independent is always the X. Because it doesn't matter what we put in the machine. It doesn't. But the output, the Y value, that is going to depend on what we put into the machine, right? It makes sense if you think about it. So the Y is the dependent. It depends on X. All right. And then we have one more blank here on each one. The X values are also sometimes commonly referred to as the domain. I don't know if you've gotten to this word yet. If you haven't last week, then this week we'll get to domain and range. And the Y is also referred to as the range. So make sure you have all of those little values in there. You can pause the video and, fill in your little doodle stuff, doodle as you go. I'm probably not going to doodle very much. Otherwise, this video is going to be like an hour. But anyways, there we go. Box 1 done. Okay, let's go on over here. All right, this one's pretty quick. I'm going to zoom in on this side. Let's do like a purple. Okay, a function is a relationship with one or more variable where each input, each number we put in, has a single output. So going back to our little machine here, you're going to be focusing this week on how to tell if something is a function. And I think, did you do that yesterday on Monday? You might have. So not everything is going to be a function. In order for something to be a function, whatever I put in has to have a unique answer that comes out. So I can't put in, let's go back to this right here with the 4 and the 9. So let's say I put in 4 again, and this time I put in 4. I do the math, blah, 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 and now I'm not getting 9, I'm getting 11. That makes no sense. So either I made a math error, or this is some kind of special, unique expression where I do get 2 different answers, and sometimes we do. But this would not be considered a function. It has to have one matching input for every single matching output. I can't plug in a number that I've already used and then get a totally different outcome. We'll talk more about that as we go. Okay, let me erase my scribbles there. Okay. Yeah, we get more into that over here with the tables. All right, let's fill in this section. You can probably tell I'm already starting to talk funny because my throat is starting to swell. Okay, each X value is only allowed to correspond with one, this goes along with what I was just saying, one Y value. Ooh, what is my pen doing? Value. What in the world? I'm sorry, guys. I'm trying to write the word value, and it is not letting me. Well, anyways, that should say value. What did I press here on my iPad? Oh, I see. Hold on. I see, it's up here. I hit the shapes thing. I should be on pen. There we go. I was trying to make shapes out of my... Okay, now let's go down here. Okay. So here, I'm just gonna label on the side, just a refresher that remember X is the input, Y is the output. Input, output. Okay, so one of these is a function, one of them is not. So this relationship is a function. This one is not a function. Let's look at Y. Okay, so when I check the inputs, I've got 0, 1, 2, 3, 4. Okay, cool. And then whatever the function is, I don't know what it is. I don't remember. Up here, we were doing 2x plus 1, right? I don't know what is being done to these numbers here. It's not telling us. But it's saying when I put in a 0, I get out a 0. Okay, great. When I put in a 1, I get out a 3. Okay, cool. When I put in a 2, I get out a 6. Cool. When I put in a 3, I get out a 9. Cool. When I put in a 4, I get out a 12. Cool. Okay, great. Everything looks good. I've got one output for every single input. Nothing is duplicated. We're good to go. That is a function. Okay, let's look at the one that's not a function. Let's look at Y. So remember, they didn't tell us what the expression is, so we don't know what's being done to the number. But when I put in the number -3, I'm getting out a 1. Okay, fine. When I put in a 2, I get out a 5. Okay, fine. Uh-oh. You see what the problem is here? I put in a 3, this time I'm getting a -1. I should be getting a +1, right? That is why this one is not a function. That cannot happen. That is a no-no. No. So if I had -3 and then if I had another +1 here, if that was a +1, that'd be totally fine. That'd be totally fine. Because the number coming out is 1 every time. But obviously it's not, so let me erase that scribble. This is what messes it up from being a function. Everything else in here is fine. Everything else is fine. Okay, cool. All right, let's go over here. All right, function notation. You will see oftentimes instead of a Y, so like, I don't have room here. I don't have room here. Okay, well, I'm going to draw a teeny tiny little baby graph over here, okay? You don't have to draw it if you don't want. X is always here, Y is always here, right? So whatever value we have for X down here, we get an output for Y, and we can graph whatever the heck it is we're talking about. Oh, let me get a swig of water. My throat, hold on. Sorry. Okay. Well, in function notation, instead of using Y, which is the dependent, because it depends on whatever X is, they use function notation, and they use f of X. Now, I know that looks really funky. That is just Y. That's all that is. It's just saying that, hey, this is my Y, this is my output. It depends on whatever the X, the input was. So we're going to use this fancy notation that's called function notation, f of X. But all it is Y, folks. That's all it is. It just takes the place of Y. The graph is still the same. Everything is still the same. Okay. So when you see this on like a test or something like that, say, and it's asking you to evaluate the function, you are literally going to just plug in the number that it tells you to find. So let's look closely at this. It says, here's my equation here. F of X, remember that's just a fancy way of saying Y, is equal to 2X plus 1. Find F of 3. So what they're wanting me to do is plug in 3 for my X. So I'm going to take that 3, I'm going to plug it right in there for X. So you can see they did it here for us already. 2, there's my X, times 3 plus 1. So f of 3, which again just means when x is equal to 3, my output, my y, is valued at, what's 2 times 3 plus 1? 7. There you go. All right, let's pop on over to the back. Okay, the back is going to go pretty quick, which is good because my throat is just about done. I also wanted to let you know you do have a standard test on Monday. I think I have, or I'm sorry, not Monday, Wednesday, which is your last day with Mr. Rabbit. So we'll have Brooklyn Shaw get the dividers out and all of that. It's got a whopping 2 questions on it. And the one on the front, oh man, I was just looking at it. It was fresh in my brain and now I blanked out. The one on the front is asking you if it's a function or not, yes or no. So that's gonna go perfectly with these, okay? So have this glued into your journal so you can look back at the sheet. So the first one will ask you if it's a function or not, yes or no, and then why. And then the back one was asking you, oh, I remember. It was asking you, let's go back to the little graph right here. It was saying, like, say this is 1, this is 2, this is 3. It would say evaluate f of, let me add a couple more here, f of 4. So I'd say, okay, f of 4. All right, let's go up. Let's say here's my graph. You'd say, okay, when x is 4, y is equal to, and then whatever that is. I'm just going to put a question mark because I don't know, maybe 10 or something. You would just say whatever the value is right there. So it's a pretty easy test. It's a standard test, question on the front, question on the back, and you're done. So Wednesday should be pretty easy. It'll be worth 4 points. All of your standard tests will be worth 4 points this semester. It just makes it easier. Okay, let's fill in this back side. So we have different formats on how to tell if something is a function or not. We've got tables. We've got something called set notation. We can tell from a graph if something is a function or not. And then we've got these weird little ones called mapping diagrams, which look like, I don't know, 2 hard-boiled eggs or something. So we have to be able to tell if something is a function, whether I look at tables, whether I look at set notation, which is just these here, lists of points being written out, graphs, so just basic graphs, and then these little weird egg-looking ones, which are called mapping diagrams. Let's fill in the blanks here first. All right. Review the columns. The relation will not be a function if any x value corresponds with more than one y value. So it's just a matter of checking for those x's and those y's. And we have to make sure that every x aligns with one single y. Remember, going back to the first page, we can't have, remember this one here? The -3, when I plugged in the -3 into the function, I got 2 different answers. I got 1, and then I got -1. So that's a no-no. So you just have to check the x and the y value. So this is gonna be repetitive all the way down because it's the x and the y value, no matter what the format is. The graph one I'm going to skip for a second. Now let's go to mapping diagram. Again, check every x value and y value. Okay. Now the graph, we have a special way to tell if something is a function. Now, this should have been taught to you guys last week on, I believe it was Thursday or Friday. I had Mr. Rabbit take very detailed notes for you guys on how to tell if something is a function or not. And we use something called the vertical line test when I look at a graph. Okay, so what that means is the vertical line can only touch the graph at one spot at a time. Feel free to pause the video if you need to get that for a second. I'm going to scroll back up here so we can start testing these. Okay, so from a table, we need to check the X's and the Y's. We just need to make sure that every X has the exact same output, a unique Y value. So let's look at table A. Here we have table A and table B. Okay, so remember the X is the input, the Y is the output. We don't know what's being done to these numbers. We don't really care. They're not asking us to figure that out. They're just asking us, hey, is this gonna be a function or not? So let's check. So we're plugging in -1. We do the function machine, whatever they want us to do, we don't know. And out comes a 1. Okay, great. We plug in a 0. We do the math on it, plug it into the machine, out comes a 0. Okay, great. We plug in a 1, we do the math on it, out comes a 1. Okay, what do you think? Is this one a function? The answer is yes. Yes, it is a function. You might have said, hey, wait a second, Ms. Castillo. I have repeating Y values. That's totally fine. That's totally fine. What you can't have repeat are the X values. And I'll write that on the side here. The X values cannot repeat. And if they do, they sure as heck better have the exact same output. I'm gonna go back up here again just to demonstrate again. With the -3, I plug in a -3, out came a 1. Great, fine. Now I plug in a -3, now I'm getting a -1. That's not okay. That's not okay. That's what we're talking about. So we can have as many repeats as we want in the Y, in the output. We just cannot have repeats in the X, the input. And if we do, the output better be the same in both cases. So this one is a function. All right, let's look at B. Okay, let's check it. I plug in a 3, I get a -6. Okay, fine. I plug in a 0, I get a 1. Okay, fine. I plug in a 3 again, and this time I'm getting a +6. What do you think? Function, yes or no? If you said no, you are correct. That is not a function, not a function. And again, just to reiterate why, this one right here. So I've got repeating 3s, and I have 2 different answers coming out for the Y's. That is not a function. All right. Next one down. These little guys were called set notation. And really all it is, it's just a set of points. See, I've got 3 coordinate points, and they're written with these little fancy curly brackets around them. I could just as easily take all of these. This is an X and this is a Y. This is an X, this is a Y. And if I hate set notation, I could literally make a little baby table here. X, Y, 3, 3, 4, -1. That's all this is, guys. 2, 3. It's just a table. I don't feel like I need that though, so I'm gonna take that off. Okay. So we're gonna check each X, make sure it corresponds with one Y value. All right, so let's erase these little lines there. Okay, so I input a 3, I do the math on it, out comes a +3, fine. I input a 4, I do the math on it, out comes a -1, great. Nothing has repeated yet, right? I input a 2, do the math on it, out comes a 3. What do you guys think? Function, yes or no? If you said yes, you are correct. Because again, the Y values can repeat. That's totally fine. What did we write up here? The X values cannot repeat. The Y values can totally repeat. That's completely fine. Okay, let's check D. What do you think? Input a 1, I get out an 8, all right. Input a 0, I get out a -2, okay, fine. I input a 1, I get out a -3. Is it a function, yes or no? If you said no, you are correct. Why? This guy right here messed it up. I've got the 1 2 times, and I've got 2 different answers coming out. That's a no-no. That's not allowed. Okay. Next up are the graphs. So, ooh, I'm really zoomed in there. How to tell if something is a function while looking at a graph. Okay, so here we've got an actual picture. I don't have a list of X and Y points to check. So we have a different method. We have a method called the vertical line test. I'll oftentimes just call it the VLT, vertical line test. Excuse me. My throat is just about done. And we wrote that over here, so don't feel like you have to write it again over here by the graphs. But the VLT, the vertical line test. So what this test says is that, let me grab a swig of water again. Ooh. Okay, it says I can take my pen, I should be able to draw a vertical line. And remember, vertical is up and down, not this one, right? That's horizontal. That's horizontal. So don't get mixed up with horizontal. Vertical is up and down. I can draw a vertical line anywhere I want on this graph, and each one of these should only touch my little U-shaped graph here at one spot at a time. Okay? Watch what happens on this one, though. I draw a vertical line. How many times is that red line touching that little U-shaped graph? 1, 2 times. That one is not a function. So it can only touch at one spot at a time. We'll do it one more time over here because I know this is kind of weird the first time you see it. So again, I draw a line here. How many times is it touching that U-shaped graph? Just once, right there, right? I can do it again, run another test. Here's another vertical line. How many times is it touching the U? Just one time, right there. We're good. So this one is a function. That's a yes. This one is not a function. It's a no. So it's pretty simple. It's just kind of weird. So you just want to draw some vertical lines, and they should only touch at one spot at a time. Okay. Last but not least, we have mapping diagrams. These you'll see in high school a lot. They're basically tables, and you're just checking the X and the Y. So let's look at this first one here. And the arrows tell you, hey, this point, oops, I didn't mean to be on highlighter. Let me go back to pen. It says this point here goes with this point here. So that would be the point -4, 16. This here goes with 4. So that would be -2, 4. So it's just a list of points. I don't know why math has to have a million different ways of representing something as simple as a point, but that's all these are. They're just a fancy, weird way of listing out points. So what we want to check, let me erase my little marks here, is we want to make sure that every X corresponds with only one Y value. So I can't have the same X value, like I can't have -4 twice and have it go to 2 different numbers here. So let's check them. Okay, so this -4 goes with the 16, fine. That -2 goes with the 4, fine. That -1 goes with the 1, fine. This 4 goes with the 16, so there is a number being used twice. It is 16, but remember that's totally fine. That's okay. It's the X values that can't repeat. So this one passes. This one is a function. Mapping diagrams are weird. I never put them on tests, by the way. I don't particularly like them. I get confused with the arrows. Okay. All right, so X. We've got 3. So 3 is giving us a 4. But then it's also giving us a 16. So do you think this one's going to be a function? No, it is not. It is not. So the 3 is being used twice. So this one messes it up. That's a no-no right there. All right, cool. We are almost done, folks. Let's go down to the bottom here. Okay. So this little example here, finding domain and range. Domain is all of the x values. And if you remember back to the front page, we wrote that. We wrote that here, remember, when we listed out all the different names for the x values, the input. Okay, range is all the y values. Alrighty. Okay, so what they want us to do is go back up to the tables, and they want us to pull out all the x values. Remember, x is all the, domain is all the x values, range is all the y values, and they just want us to literally list them here. So I'm gonna go to table A and B, so let's scroll back up. Table A and B. Here's table A and B. So all of the x values, there we go. -1, 0, 1. Go back down. -1, 0, 1. This is so easy, you just literally list them. And then the range, all the y values, 1, 0, and 1 again. I don't have to write the 1 twice, it's okay. So just 1 and 0, there we go. And I don't want to put parentheses around them because now I'm making it look like a coordinate point, so just leave it without parentheses. Okay, table B, let's list out all the x values. Here we go. Table B, all right. 3, 0, and 3 again. Remember that one was not a function because the 3 repeats twice. And all the y values, -6, 1, and +6. There we go. Okay, let's do that with C and D. C and D, I believe, were these little guys here. Okay, so all the x values, so 3, 4, and 2. 3, 4, 2, 3, 4, 2, 3, 4, 2. And all the y values, 3, -1, and 3 again. 3, -1. Okay, I'd like you to pause the video and try filling out D, E, and F. All right, if you paused the video, hopefully you got these correct. I'm just gonna fill in the answers. Let's see if you guys got them correct. So all the x values, AKA the domain for D, are 1 and 0. All the y values for D were 8, -2, and -3. Okay, E, this one was tricky. I'm gonna skip E for now. Oh, F is just as tricky. Okay, so E, if I look back at graph E, would you guys agree with me that these arrows mean it goes on forever to infinity, right? And it's gonna get wider and wider and wider as it goes on. So this is kind of weird, but it's gonna be infinity, all real numbers. It's going to stretch from -infinity to +infinity. And then the range is the y value. So that's going to go from bottom to top. So it starts at -1 and it's going to go to +infinity. -1 to +infinity. Okay, and then F, the x values from left to right, it starts at, what is that, -2, and it's gonna go on forever to +infinity. Those are the x values, -2 to +infinity. And then the y values, that's from top to bottom, and again, this thing is gonna get wider and wider and wider to infinity, so it just goes from -infinity to +infinity. My infinity symbols look weird, don't they? I do want to let you know, don't worry about like these ones right here. As long as you understood A, B, C, and D, you're in good shape. Okay, cool. And then this last one we are going to skip. All right, guys, that is it. I hope you feel a little bit better on what a function is, how to tell if something is a function or not from a graph, and then from looking at the x and the y points if you've got like a table or something like that. I miss you guys. I will see you on Thursday. And remember, you have a test on this Doodle Notes standard 8.f.1. That will be tomorrow with Mr. Rabbit. All right, see you guys Thursday. Bye-bye.